Good morning to all. Today we're going to discuss a topic on industrial robotics in the subject CAD, CAM and automation. Industrial robotics is one of the main in manufacturing and the productions because nowadays all the manufacturing companies required the automation process. The automation is booming because of these kind of robotics and IoT things. Then we're going to see some of the five major key points in this section. The robot anatomy, robot control systems, end effector, industrial robot applications, robot programming. Where robot anatomy is nothing but where the kind of robot is will be discussed. Robot control system as like the CPU, when the robot control system also is available, it occurs during the time of the machine control. End effectors, it having some the tools like wrist, arm, bridge. These are all some of the parameters of the end effector. Industrial robot applications. In industrial robot applications, many of the countries, many of the companies are using this industrial robot, and then robot having the programming languages. Industrial robot defined. The definition: industrial robot is defined as the general purpose programmable machine processing certain anthropomorphic characteristics, where the human will not work on that place where we use this robot, industrial robot. Here, that some of the places where we use the industrial robot are hazardous work environment, a repetitive work cycle, consistency and accuracy, the difficult handling task for the humans, where the thermal areas where we use these kind of robots for the purpose of handling the machines, and then multi-shift operations. Nowadays we are applying the FMS and the IIoT concept in almost all the industries, so that and that multiple operations to be done at a time. So that in that case we use this industrial robot. Reprogrammable and flexible, as I discussed in the flexible manufacturing system, the industrial robot is one of the main concept that where we can reprogram the program as the applications required in the manufacturing unit. Interface it to other computer system. Easily we can interconnect the many of the systems to monitor the work done. Robot anatomy, where the consist of joints and links. Joints provide a relative motion. The links are rigid members between joints. Various joints are available in the robot anatomy, that linear and the rotor, where linear will go the to and fro and the rotor will rotate based on the degrees of freedom. Where here the degrees of freedom is of the major concept in the robot anatomy. It is like a human hand, it will rotate accordingly to the pick and place the object or the workpiece to the machine. And then the robot manipulator consists of two sections, where body and arm, and then wrist assembly. Body and arm is nothing but the positions of objects in the robot's volume. Wrist assembly for orientations of the objects. And then manipulator joints. We have these kinds of types of joints: translation motion and the rotary motion. Translation motion is a linear joint where the input link and the output link. This go the to and fro of the left and right corner. Rotary motions, where rotational joint, a twisting joint, and then revolving joint. Rotary motions having the three types: a rotational joint, a twisting joint, and then revolving joint. The joint notation schemes uses the joint symbols like L, O, R, a TV, like for the during the programming languages we use these kind of joint notations. And then a polar coordinate, a body arm assembly, where this is the diagram we use in the polar coordinate. This is an you see this is an robot uh, wrist and assembly, where we can keep the workpiece to fix in the machine. Cylindrical robots and arm, and then Cartesian coordinate and body arm assembly. We have different types of robot arm assembly, jointed arm assembly, and then SCARA robot. I think many of the assembly areas we use this SCARA robot. It is like a human, it will work in 360-degree rotations. SCARA stands for Selectively Compliant Assembly Robot Arm, similar to a jointed arm robot, except the vertical axis are used shoulder and elbow joints. Here, this SCARA robot is then mainly we use in the automotive sector, like in the car assembly in different areas. These are the SCARA robot about occasions. Wrist configurations. Wrist assembly is attached to the end of the arm. End effector is attached to wrist assembly. Functions of wrist assembly is to orient end